Alright guys, this is a video to just update you on what I worked on last night. Uh, Basically, I made a rotation manager, right? Uh, this is the sample scene. I'm running on 2018.3.7. I think point 0.8 come out like earlier this morning, but last night it wasn't out or something like that. I got the most recent version of stable Unity and it was point 0.7. Uh, anyway, I have a level here, and on this level is a script, and this is a cube to kind of simulate the level. It's just a normal cube, right? And it's going to be parented to the level, right? Everything's going to be parented to the level where this rotation manager is. And basically, let me just show you quickly the end result. If I hit Q, the level rotates left. And if I hit E, the level rotates right, right? And then there's a bunch of rotation settings here, so we can change the rotation speed by the value goes from 0 to 1, and depends on alert value. I'll explain that later. And then all of this other stuff is for debugging. It checks if it's rotating or not, and it only enables when it's rotating, and then it disables when it's not rotating. So we can use that for like checking, make sure that everything is kinematic in the level, and then releasing it whenever the rotation is complete, right? And there's a rotation queue here, basically, that checks like how many inputs that I've added. So I'm just spamming keys now, and you can see that there's a bunch of elements being added, and it'll auto complete the it takes in it acts as a rotation queue and takes in player input and stores that information, right? And then the level settings we can mess. I haven't done anything with that yet. This is just for future. If we wanted to make the level manager part of the rotation manager, we could absolutely like control what the current level layout is, and then have an array of level layouts that it'll initialize and stuff like that. So moving on to the script real quick. I'm gonna move over to my desktop capture left. Okay, on this script, this is the script here. I have the header, that's rotation settings, right? If you're wondering what the serialized field is, it just basically makes it private, but allows me to mess with it in the inspector. It's better than having it public, just so we don't end up like fudging with each other's codes by calling, a variable accidentally in another script, right? So like if you like, for example, if someone else had a script and they hit C and then hit tab, and it won't ever change the current rotation of the level or the destination rotation of the level, right? That's all. Yeah, we don't necessarily need to do that. It's just to protect the script from breaking. So this rotation settings, right? This is a public bool. It just determines whether or not the level is rotating. This float is just a float to store the current rotation value. This float is used to store the destination rotation value, where it's going to rotate to, and it's set to default by 0. This limited rotation bool, I haven't done anything with it yet, actually, but basically this will determine whether or not we want to have the rotation cooldown or not. And this rotation cooldown, I haven't done anything with it yet, but that'll determine how long the cooldown is in seconds. So here's the rotation speed, right? Sorry. This is a float to determine the lerp speed, and the values from 0 to 1, with 1 being the fastest, or like instantaneous rotation. I'll go into that later when we get to the math f lerp, which is like way down here. Here's a list that acts as an input queue. So a list is like an array, except you can add stuff to it and subtract, and then like take away like index or elements, right? So array is like, for example, you have an array of 6. There's always going to be six like spots or like elements for objects to be in, right? But a list, you can constantly add stuff and subtract stuff, right? And so for the time being, I know we don't have like a limit on like how many times a player can rotate the level at the moment, so this is still like in the air, right? We can obviously add a cap, like a cap, if we wanted to, but this acts as the rotation queue, and it just stores the amount of times the player rotates and what direction that they do so, all right? In bools, and I'll get to that in a bit. So level settings, we can ignore that because I haven't done anything with that yet, right? So in start, we initialize the level, right? And initializing the level, just I print level initializing at the very beginning, just to make sure, just to check if it's supposed to initialize when it's, check if it initializes when it's supposed to. And this just makes sure that whenever we start the level, the current rotation is always set to 0. It sounds a bit redundant, but I'm just wanting to, like, if we end up doing the level manager thing, it's good to have this here so we can call the initialize level whenever we want to switch to a different level, and it makes sure that the current rotation is set to 0, like a flat value 0, so there's no weird decimal places being added, and the entire level becomes asynchronized, right? Yeah, and so if we choose to use the built-in level management, the level array integer would be declared here, right? So this function, rotate level left, is obviously called when we want to rotate the level left, right? It's being called at update here, and it just checks, right? If input get button down, rotate left, right? So you're wondering why it's get button down instead of get key down, and this is because, like Unreal, if we move over to our project settings here, you can declare like your own axis and stuff like that. So I changed. So this is, I have rotate right and rotate left here. Rotate right is Q and rotate left is E, even though they both do the opposite things. I haven't renamed them yet, and you'll see why it's weird like that in a second. I know it sounds backwards because you'd think Q would go to the left and E would go to the right, but let me show you why. This took me a while to figure out. I was wondering why it was going backwards, and I just thought, screw it. I mean, it works. We'll get to that. So moving back to but basically the whole point is that you can declare these, right? And you can add a whole bunch of like, you can add different keys to it, right? From what I understand, this gravity dead insensitivity stuff. I can explain if you guys want to later. Basically, I originally didn't even add this input, right? But my roommate Christian suggested adding this if we wanted to have it be used for phone and keyboard, so you can actually, like, you can have multiple things bound to the same thing. It makes it easier in code, right? Because you don't have to call get input key down Q and then have a separate get input key for, like, rotation for a different device, right? You can always just change the bindings here. So now moving back over to the script. So this is just called whenever we hit rotate left, right? And it adds a true bool, right? The name is basically irrelevant, actually. I made it rotation left just so it can be easier to understand. But it adds a true bool to the call stack, to rotation Q, right? And the rotate level right adds a false bool to the rotation stack. I decided to go with bools because they're binary and you can't fudge numbers. It's literally on or off, right or left. That's the only thing that needs to be found. So this is where I spent the majority of my time last night, at the moving function, right? Moving's constantly called, right? In update, it's constantly checking for update, and it also constantly, it has to be in update because the mathf.lerp, the interpolation is always happening, right? Like, I can't put that into one single thing, and for, like, I can't put that in just rotate level right or rotate level left because it constantly has to be checking, right, to make sure that stuff is moving. So looking at the code here, right, there's two parts to this, right? There's part 1, which is finding the level value, and part 2, which is just moving the level. I'm gonna go ahead and just relabel that. So part 1, part 2 isn't that difficult, right? It's just it basically takes a transform of the entire level game object, and keeps the x, keeps the y because those aren't being changes, and changes it by rotation value or rot value, right? And this float is determined at the very end of all of this, right? So part 1, finding the lerp value, right? At the beginning, it sets current rotation to be what the current rotation of the level, the z, is, right? And that sets the z for the entire level to be the current rotation. This stuff is used to snap the level, and you might be wondering what that is. Basically, with mathf.lerp it gets weird. I found this out last night, but sometimes it would rotate to, like, for example, if I went from 0, or if I went from, like, 180 to 270, it'd go from 180 to 269.9999, right? For repeating. It wouldn't actually hit the flat value of 270. And what this did was that it killed the game, because you can't, at that point, current rotation will never equal destination rotation, and no other inputs can be added. So I thought, okay, you know what? If it gets close, if it gets within 1, it's basically the same thing, right? It'll snap to the actual raw value, and make sure that it will always be this will always like eventually become true, right? Because this entire stack is basically, or this entire bit of code is basically the what moves the code, right? Or what moves the level. So if the destination rotation is 0 and the current rotation is greater than or less than equal to 359 degrees, right? So basically, because another weird thing I found out is that Unity, you can input, if I go over to desktop left here, or desktop right, I can input like whatever value I want here, right? I'm gonna really quickly pause this. So if I wanted to enter -90, it'll go to -90, right? But what I didn't get, like what took me forever to figure out, is that for some reason, using mathf.lerp angle, it's capped from 0 to 360 and will not go below or above, right? So it basically, like 0 equals 360, right? In terms of degrees, and you can't go anything below 0 or above 360, right? So this is here, right? To check if it's to snap the level when moving from 370 degrees to 360/0 degrees, right? So if the destination rotation, so where we're moving to, is 0 degrees, and the current rotation gets to 359, like 359 degrees, it just snaps it to 0 degrees, and then it's basically it's like the level is back to 0 degrees, right? If it's not this, so else if the current rotation is less than or greater than or equal to the destination rotation -1, so and the current rotation is greater than or equal to the destination rotation +1. This is basically, imagine like a 1 degree buffer between like around each destination rotation, right? And basically, once the current rotation, as it's rotating, gets to that buffer zone, it just snaps it to what it actually, to the destination rotation is. And so you'll know that it'll always hit that flat value of 270, 90, 180, as opposed to like 89.99999, or like, because that took me forever to figure out, and I don't understand why Unity doesn't do that. But it just, like, mathf does, like, for some reason doesn't go all the way to the value sometimes, and it's really weird, right? So this is there just as a safety net to just snap the level when it gets close enough to that, to where it is, right? Oh shoot, I've been in the wrong thing. Okay, sorry about that. Hold on. Okay, fudge. Where did I end that at? Okay. Yeah, so like going back, this is used to check if this snaps. Sorry about that, guys. This is used to just check. Imagine, like, for example here, else if current rotation. I'll go back over the stuff. This is used to check when snap the level and moving from 270 degrees to 360/0 degrees, right? Else if current rotation. This is the 1.1 degree bubble that I was talking about, yeah. So basically 1 degree below and 1 degree above the destination rotation. If it gets to around there, it's good, right? It'll snap to the spot. The reason why I have an if statement is that the weird thing with 0 and 360 being the same, right? Except that you can't go above 360 and you can't go below 0. So this will make sure that it'll snap in that one specific instance, and then this will check for the rest of the times. Like I said, it's Unity's got finicky sometimes. It's finicky. It's super finicky sometimes. Okay, so this is where the bulk of the main stuff that I was working on happened, right? Last night. So if the current rotation is the destination rotation, right? Is rotating is false, right? Because it's no longer rotating. The current rotation made it to the destination rotation, right? if there is more than one thing if there's more than 0 things basically in the rotation queue, it checks it. So if the first index, which is 0 because it's n minus 1 for like it counts from 0, so 0, like for example, if there was an index of 4, it goes 0 1 2 3, right? It starts from 0. So if rotation queue 0, the 0 index, is true, we rotate left, because remember when I said here we declare rotation left here, right? So that'll be true, and then rotation the false is rotate right. Right. So if it's true, it'll subtract 90 degrees. It'll rotate by negative 90 degrees. Is what I originally thought, but it gets finicky, right? Like I said with Unity, it gets finicky. If I hit Q for some reason, let me move back to the other desktop, right? And let's go back to these project settings, right? And so rotate right would be E, right? And rotate left would be Q, right? But if I hit, so I'm going to hit Q here, right? And it rotates it right for some reason. And I don't know why that is, even though I declared that it was negative or adding 90 degrees, right? I'm hitting Q, and that's supposed to be rotating left. So that's why, for the purposes of this, is where I just decided, you know what, screw it. I can just rebind these, and it does the exact same thing, and it works, right? I mean, I guess what I could do. Let me go change the scene again. What I could do is rotate, like just change these values, but I don't want to fudge with this code because I know it works, especially with this bit, right? So let's just imagine. So this is actually like, let me see the true bool. This is actually rotation. This will be technically, yeah. For all intents and purposes, the rotation left and rotation right thing doesn't matter because we can rebind them. It's just the functionality that matters, right? So if the current rotation is 0, right, and you subtract 90, because the degrees can't go negative, it just sets the destination rotation to 270. So it doesn't go like, you can't go 0, you can't go negative 90 degrees, right? It'll just go to 270 and it'll work, right? The rotation will work fine. If it's not that, it'll just subtract 90, the destination rotation by 90, and then the current rotation will move to follow that, right? And then it'll also, the last thing it does is rotating to true. So just make sure that everyone knows that, hey, this thing is rotating, right? So here's, and then else. So this is the other thing. So if rotation Q is true, it'll do this stuff. If it's false, so rotating the other way, it'll add 90 degrees, right? And because it can't go past 360, this acts as 270 plus 90 degrees, right? Just because the MathF lerp angle clamp is super weird. And then this also sets the rotation bool to true, right? And then at the very end of all of this, right, it removes the completed action. So it just removes whatever's in the 0 index, right? It just clears that, so it moves on to the next thing. And then it'll go over here, and then it'll keep running it, and then move to the next thing, right? While all this is happening, this just determines whether or not all this does is add or subtract 90 degrees from the destination rotation. All of the lerping happens here, right? Basically, it creates a rotation value that's equal to mathf.lerpangle, which is the and it lerps between the current rotation to the destination rotation. So from current to the destination at a factor of the rotation speed. So this is the variable that I called forever ago here. It's set to 1f, but that's instantaneous. It goes from 0 to 1. So I actually have it in the inspector here. Let me switch back over. In the inspector here, I have it set to 0.1. That's how fast 1 is. If 0.1 is going pretty fast here early, right? Like just to demonstrate, actually, if I set the rotation speed to 1, I go Q, it'll instantly snap, right? But if I set the rotation speed to like 0.1, you have like a reasonable like lerp. So it's not like it doesn't freak the player out. The player knows exactly what's going on when they rotate the level. Okay, so then moving back over here. Yeah, so this this is the rotation speed that it changes, it factors, it multiplies. It's the speed between, sorry, the speed between current rotation and destination rotation. Okay, and then the second part, which is literally like, it was super easy to figure this part out. It just takes the transform of the level, right? Transform.Euler angles. Uh, and I say Euler angles because we're dealing with 0 to 360 degrees as opposed to quaternions, and I don't want to mess with anything to do with quaternions. So transform.Euler angles equals a new vector 3. It just takes the and the reason it's a new vector 3 is because I couldn't just change the z value. I had to change the x, y, and z value to set a new vector 3. Basically, it only takes in a new vector 3. So I just kept, it just keeps whatever the x is and keeps whatever the y is, because those two things doesn't matter, and it just constantly updates the new z value with the rotation value float, right? All this work basically to rotate a level left or right at a consistent 90 degrees, and it'll always be 90 degrees. It'll always snap to that 90 degrees, right? Okay. So anyway, that's been the script that I worked on last night. Uh, if you guys have any questions, if I went too fast, I'm down to explain it over Discord and stuff like that. But I just wanted to update you guys on how the core functionality of the rotating of the level will work. All right. I'll be on Discord if you need me.